Hello, my name is Axel Scherer. I will give you a quick introduction into factory methods in UVM. Factory methods create a lot of flexibility in your verification environment. They basically avoid hard coding and creating a lot of dependencies. So when you do a construction of an object, you can do it on the fly. Implicitly, this will make your code much more stable. First of all, you need much fewer code. Right? The dependency chains will be broken and you can basically change anything anywhere in the system very easily. Let's look at an example. In a classic way, let's say we have a class called mid and we want to create an object inside of the class. The object will be of type class bottom. This is how we would do it, right? We basically use the constructor new. All good and dandy, and this works fine. But let's say we have a different kind of application of the same system. How are we going to deal with this? Now we have an alternative class. Now I can derive this class bot alt from the original class bot. That saves me some code. That's good, and we certainly will do that. But what's the effect of actually using this? I would have to change actually here my instantiation to make this happen. In effect, this means I would have to change my class mid. And if class mid is also instantiated at a higher level, I would have to change that as well. Right? Implicitly, you see where this leads. You have a ripple effect of a little code change at the bottom going up through the system. That creates a major maintenance nightmare. Using factory methods will solve this problem. We start again with our class bottom and want to create an object here. Instead of using the new, we're using the factory method create. By default, it will still create an object of class bot. But we can now easily change this, right? We can now say, hey, I need class bot alternative. And we can use a factory override method to basically change the behavior during the construction. This change of behavior does not influence class mid, so the structure will stay the same, and you have enormous flexibility at any layer of your hierarchy to swap things around, right, and change things as you need it. Let's look at this in terms of a interface UVC. Let's say we have our agent with all the subcomponents, and now you have some changing requirements, right? You don't have to change the agent anymore. In the past, you would have to do that. You can just take your driver, the new driver alternative, and do an override. And again, the code for all the agents and the UVC on top of that and the test bench on top of that all stay the same. Let's look at some actual code for this. Here we have an agent, just like we saw it. This is an APB master agent. Okay, so it will have to create its environment, and this happens down here. Let me go down further. Where is it? Overshot. Here we go. You can see when the sequencer is created, the subcomponent of the agent, it doesn't use the new constructor. It uses the factory method create. And the default type is APB master sequencer. Okay? So if you build this and you don't tell the system anything, it will create a sequencer of type APB master sequencer. But you have the opportunity to overwrite what type the agent should create in the system. And the agent will stay the same, right? It will not notice the change by itself. It will all happen on the fly. You can find more videos like this either on this YouTube channel or at the video library for the Incisive Simulator at support.cadence.com. Thank you very much, have a great day, and talk to you soon.